and it's also our last day of learning new factoring strategies. So I have one more factoring strategy. It's really quite similar to the other ones we've already learned. So our goal is to learn how to factor polynomials that have 4 terms. So we've done GCF. That could apply to any kind of polynomial. We've done difference of squares. That's if it's like a binomial, and there's 2 perfect squares that are being subtracted. We've done trinomials. That was yesterday, quadratic trinomials. Well, today we'll talk about what if you have a polynomial with 4 terms. And then after that, we're going to talk about a general strategy for factoring polynomials, because usually whenever you're looking at these things, you don't have a teacher or the direction saying, hey, use the box method, or hey, take out a GCF. It just says factor, and you have to know what method to apply. So our second topic for today is to just look at polynomials and know what strategy should I use here. Okay, so we're going to learn one new strategy, and then we'll talk about a general strategy for all polynomials after that. All right, so let's go ahead and take a look at this one here. So here's the cool thing about it. It's box again, so there's not a whole lot new going on here. So you start the same way. You're still going to put the first term in the top left box. You're still going to put the last term in the bottom right. Yeah. Now, the other 2 terms are going to go inside the box also. And it doesn't matter where you put them. I usually just put the squared one here and the other one here, but it doesn't technically matter. Okay? But what does matter is the first term goes in the top left, last term goes in the bottom right. The other 2, it doesn't matter, but just put them in there. And our job is to figure out what goes out here. Okay? Now, it's a little bit easier than the last one we did, because in the last one we had to do a lot of guessing and checking. On this one, if you know how to take out a greatest common factor, there's no guessing. You'll get the answer right away. So let me show you. To find this box up here, the top left one there, what you're going to do is you're going to look at the ones below it. And you're going to ask yourself, what do they have in common? What can I divide out of 2 and 12? We could take a 2 out. And what about r's? How many r's can I take out? Only 1. That's the thing that has to go there. So there's no guessing. If you know how to take out a GCF, you can get the answer right away. Okay? Let me back up a little bit. I want to get rid of that green, though. So now we know that 2r goes here. So to do the next box over, this one, we're going to look at this row. What can we take out of there? Any r's? No r's this time. The 30 doesn't have any r's to give. So this one is just simply 5. Now to get the blanks over here on the side, we go horizontally instead. So that's not the highlighter. Here we go. What can I take out of those 2? Okay, good. I'm hearing all good answers. So first of all, the 2 and the 5 don't have anything in common. So the biggest thing I take out is a 1, right? But we can take out some r's. They both have at least 2 r's, so I can take out an r squared. Okay? Last row here. What do you guys think? I think 6 is the biggest as well. Now, with this strategy, I would recommend, I'll write this, I recommend checking your answer. Before you call it quits, I would make sure it works. Because it's possible that your answer doesn't give you the correct answer. And that would mean one of 2 things. Either A, you did your GCF wrong somewhere. That's possible. Or, actually, that one, if you did everything right, and it still doesn't work, that means that polynomial just can't be factored. Okay, so I would advise checking it. So let's check. Does 2r times 1r squared make 2r cubed? Does this times this make this? I think so too. Does 1r squared times 5 make 5r squared? And does 6 times 2r make 12r? And does 6 times 5 make 30? And we're good. And we're good. Okay? So we have our answer. And the answer is the thing on the top, which is 2r plus 5. It's a positive 5 because it's a plus because it's a positive 5. And then r squared plus 6. And that's it for that one. So it's just the box method again, mixed with the GCF method. A little bit less guessing is going. There is no guessing on this. It's a little bit better than the last box method, which has a lot of guessing and checking going on. Now, I don't plan on giving you guys ones that don't factor. It could happen by accident. So that's why I'm saying I recommend checking your answer. We good to erase, guys? Anybody? Okay, so give that a try, see how you do. All right. David, what goes here? Good. And Adrian, what goes in the bottom left square there? Mm-hmm. Now, I like I said, I like to put my squared one here and the other one here. But if you did it backwards, it's okay. It's just that the answer I get on top, you'll have it on the side, and vice versa. All right, so Adrian, what can I take out of these two? Good. Good. Kevin, what can I take out of these two? Hmm? 7. And notice how they're both negative. If they're both negative, you could take out a negative. Now, there is an exception where you still would want to take out a negative, even though they're not both negative. And that will become obvious when you do that thing where I told you, like, check your work at the end. And I'll show you an example if I remember after this of when that will happen. But let's take a look at our next one. Michael, what can I take out of these two? 12n cubed and minus 14n squared. These two. So 7 goes into 14, but it doesn't go into 12. Yeah. So what's the biggest thing that goes into 12 and 14? Yeah, I think so. And how many n's can we take out? This one's got 3 and this one's got 2. So the most I could take out is, you take out 2. Because they both have at least 2. Like this guy's got 3, so he can give away 2. And this guy's got 2, so he can give away 2. So we could take out 2's n's. All right, let's look at our next one. Alondra, what can I take out of these two? 3, yeah. All right, and then I'm going to check my work just to make sure it works. This times this makes this, yeah. This times this makes this, yeah. This times this makes this, yeah. And yeah, so we're good. Now, I want to show you guys an example of a situation. If you ever have something like this, and this might be worth, I don't know, writing down. Let's see, I think you were both trying to remember how this works. Hold on. Okay. Sorry. Just doing some brain work. Have you ever had this kind of a situation? You guys know the A goes here, the D goes here, and the other two go here, right? Okay, now in this case, it doesn't look like you would take a negative out here because one's negative and one's positive, right? It doesn't look like you would take a negative out here because, once again, one's negative and one's positive. But do you guys agree that there has to be a negative out here somewhere? Because otherwise, there's not going to be a negative on the inside. So there has to be. So here's the situation. When you have this situation, this will be a negative number, and so will this. Why? Well, this negative will give me the C, and this negative will give me the B, Guess what happens when you put two negatives together? That's why it's hidden there, okay? So it's kind of hidden. So watch out for that. So that might be something worth having in your notes just to remind yourself of. If you ever have a box where you have a negative on the diagonals only, then both of these are going to have to be negative. Another way that you can find that, though, is just if you check your work every time. You're like, it's not working. What can I do here? And you'll kind of work through that and see if you figure it out. But that's a special circumstance to kind of be aware of with this strategy. All right? All right, so that's our first objective for the day, is our last factoring strategy. Now we're going to look at a general factoring strategy. In other words, I should be able to just say to you, here's a polynomial, now factor it. And you have to know, is this a GCF problem? Is this a difference of squares problem? Is it a box problem? What is this? So I'll show you guys how to make that decision now. Am I good to erase? Oh. All right. Here we are. Prime polynomials. All right, so before we begin, let's talk about this. A prime polynomial is a polynomial that cannot be factored, so you can't do anything with it. Here's an example. Linear, this is something you guys should write down. Linear binomials we're going to call those prime. In other words, if you've got two terms and if the highest power is a 1, a linear binomial, then we're going to say that's prime. You can't factor it anymore. Here's another one. We talked about this one a little while ago. We learned the difference of squares method, but this is a sum of squares, and those cannot be factored. So if you ever see one of those, you can't do anything with it. Leave it alone. Now this one, there's no way to tell just by looking at it. You just have to try. Okay? But if the box method fails. So, that's an unfortunate one, because maybe the box method's failing just because you're not getting the right numbers in there. All right? But if you're doing everything right and just nothing's working, you just can't get it, that means that polynomial just can't be factored. So that one's kind of the worst one, because you do all this work and you realize, oh, I can't do it. I was wasting my time the whole time. But these two you can tell right away. Okay? If it's a first-degree binomial, linear binomial, nothing. If it's a sum of squares, nothing. You're done with it. Am I good to erase? All right, so let's talk about a general strategy for factoring. So for all polynomials, you always, and you guys should definitely write this down, always take out a GCF if possible. You always start there. So no matter what polynomial I give you, you should always be looking for a GCF, if possible. After that, what method we use depends on how many terms are there. Okay? So, if there are two terms, then maybe it's a difference of squares. Draw the shape there. Difference of squares. Now I'm going to put a question mark because it might not be. You might, at that point, you just might be done. If it's not a difference of squares, you've done all you can. So, okay, but maybe it is. All right. If there are three terms, I wonder if I should do it that way. If there's 3 or 4 terms, we're going to use the box method. Okay, so if there's 3 terms or 4 terms, we're going to use the box method. So you always, sorry. That's the difference of squares. Why don't I write it so to prevent that from being confusing? I'm going to change that to squares because I don't want you guys to think that means box. It means square. Good morning. So 2 terms is difference of squares, and I'll put a question mark. 3 or 4 terms is a box method. Now, at that point, you just have to ask yourself, can I keep going? after you do the box method, you might have those two things that you get as a result. One of them could be a difference of squares. So you might get to factor again. Okay? But there it is. So step 1, you always start by taking out a GCF. Step 2, and by the way, that's a question mark also. There may not be a GCF. Okay? But step 2, if there's two terms, the only thing that you could possibly try is a difference of squares, and that's a question mark. If it's not a difference of squares, then don't do it. You're done. If there's 3 or 4 terms, then I'd say try the box method. Okay? So that's our general strategy for factoring. So once again, when you're taking a test or something you're doing, they're not going to say use this strategy. They're just going to say factor, and this is the process you go through to do that. Okay? Am I good to erase and move on? All right. All right, so I think I thought I had some examples. I hope I have some examples. I think I did. I do. Great. All right, so go ahead and write down example 1 here, please. Go ahead and write down example 1. This might be coming out of left field. You can write this. Maybe it'll make sense to me. I'm not sure. We'll see how you do. Okay. Yeah, absolutely. Yeah, you guys can write on the back. That's fine. So notice I'm not telling you what strategy to use here. I'm just saying, hey, here's a polynomial. Factor it. So let's begin and see what we can figure out. All right. So Shakir, what's the first thing I want to do if I want to try factoring? Huh? What's the first thing we try? Okay, so I'm not sure. Let me try another person. If they're not sure, I'll take a volunteer. But Brianna, what's the first thing I'm going to try? We are going to do the box. I like that you said that, but that's not where we're going to start. What do you think, Crystal? We start by looking for a GCF first, okay? So let's see if you guys can find a GCF. Take out a GCF there if you can. If you don't know what I mean by that, I'll get you started. Take out a GCF. That's where we always start. You won't always have to do this. If you look at anything, there's no GCF there, then move on. We will, but we start with GCF. Always start with GCF. Lil, you got that GCF? All right. How was math late yesterday? How was math late yesterday? How bad? Last place?
Yeah, I didn't get one right.
Can you go in the corner? Put your face in the corner for the rest of
I'm good.
All right.
Edwin didn't do good either. He got all zeros.
Really? Must have
Yeah.
been a hard question set then. All right. So Niana, what did you find a GCF? What did you find? 8? There is a GCF, but it's not it. So I'm looking for something that divides into all 3 of these. And 8's not quite it. But I'll give you credit for noticing that we do indeed have one. I'm going to ask, not Miles, he's gone. Ask Steve, did you find a GCF?
Oh.
No? Okay. All right. So yeah, go ahead, Denise. Huh? Yeah, what is it? 2. Good. 8, 26, and 6 can all be divided by 2. That's the biggest thing I can find. Also, they all have at least 2 V's to give up. Now let's do it. So 8 divided by 2 is 4. 26 divided by 2 is 13. 6 divided by 2 is 3. Yeah, I'm going to do the V's next. Now, if I take 2 V's away from this one, how many will I have left? 2. How about this one? And this guy? 0. So we started with our GCF. That was first. GCF is first. All right. So Denise, what do I do now to factor this? It's not. The box method. Now, Steve, how do you know that this is the box method? It's a beautiful question. Anybody know why I would use the box here? Because it's got 3 terms. Okay? So it's got 3 terms. So here's a box method problem. Now, after I do the box, we're going to still have this guy. But the box is going to break that trinomial up into 2 binomials. So now I'm going to just kind of do this on my own a little bit quick because I don't want to spend too long on examples. I want you guys to practice more, but I just want to show you the process here. So don't write until I'm done because I might guess wrong. So give me a second. I guessed wrong. Aha, I got it. All right, you guys can write this now. So I'm just kind of buzzing through that. We talked about that yesterday. We're going to get a chance to practice a little bit more of it today, but there it is. So I'm going to ask a question. Why did I start by taking out a GCF? Next time I ask, I want everybody to know. Ready? Why did I start by taking out a GCF? Because you always do. You always start by taking out a GCF. Next question. How did I know to do the box method? Because there was 3 terms. You guys knew that one. So why did I start with GCF? You always start like that, right? And then why did I do the box? Because there are 3 terms. All right. Can I erase? All right. You go ahead and write down number 2. I'm going to try to spend a little less time on the examples because I'm not really showing you anything new in terms of how to factor. I'm just teaching you how to make decisions. So I'm not going to spend too long on the strategies here. Just want to make sure you guys know the decisions you have to make. That's the new part. How do you know what to do? All right. Leah, if you want to see a grown man cry, you're going to miss this answer. But if you want to fill my heart with joy, you're going to get it right. Okay? So we're going to see how this goes. What do I do first? She brought me joy. You're going to find the greatest common factor. I think there is one. Thank you, Leah. You blessed me. All right. You always start by looking for a GCF. All right? And I think this one has one. I think it's a little bit hard to see, but both of those can be divided by 3. So I'm just going to write it, and I'm going to show you the answer. I'm not too worried about you guys figuring that out right now because you've already done it before. It's going to take a little time. You'll get time to practice, but I just want you to know how to make the decision. You always start by looking for a GCF. Okay. Now the next one, I won't cry if you don't know because, it's been a minute since we talked about this, but we'll see. Lily, what do I do now to factor this? Good. And the more full answer is difference of squares, right? Is this a difference of 2 perfect squares? It is. So we're going to do the difference of squares. Now, we haven't seen this in about 2 days. So I will briefly review with you guys how that works, okay? But now, an important question, Lily. How did you know it was difference of squares? Okay, so you just recognize that's a difference of squares. Another one is it's only got 2 terms. If it's 2 terms, we're going to see if it's a difference of squares. So yeah, you're right. 2 terms, let's try difference of squares, and it is. Good job, you remembered. Good job. All right, one thing though, I want to show you something before we call it quits. All right, so here's how this one works. It's been a while since we've done it. If I split this up evenly, what times itself gives me 16? And what times itself gives me a squared? a squared. A. So this one's 4a and 4a. How about this guy? What times itself makes 25? We make 1 a plus, you make 1 a minus. And here, don't forget this. This is the easy part, and this is the part I want you to see, Leah, is that 3 is still part of the answer. So put that in the front. Okay? So I'm going to ask the question. I'm going to ask, why did I start with GCF? You always do that. Does that mean there will always be one? No, but you always check. Second, why did I do difference of squares? Because there were 2 terms. Will it always be a difference of squares because there's 2 terms? No, so you need to know what they look like. They have to be 2 squares being subtracted. But if they are, then you're good. All right? All right, one more, and then we'll let you guys practice on your own for the rest of the block here. All right, so let me ask Azalea, what do I always start with? We want to find a GCF. All right, there isn't one. There's no GCF. I'm just going to put no GCF, but I just want to write that to make sure you know we're supposed to check. Okay, so nothing there. Now I'm going to ask Crystal, since I couldn't take out a GCF, now I move down my tree. Boy. Now I move down my tree chart. What method do I use to factor this? The box, because there's 4 terms. So, and this is what we did earlier today. Once again, I'm not going to spend too long working it out. I'm just going to show you the answer because we've already practiced this. I just want to make sure you guys know how to make your decisions. Okay, so I've got x plus 1 and x to the 4th minus 1. So I did the box because there were 4 terms. I bet you guys would be tempted to stop here. But remember that little chart I gave you guys? How do you factor? General strategy for factoring. What does it say at the very bottom? See if you can keep going. All right. Can I do anything to this? Look at your slide that talks about primes. Look at the slide that talks about primes. Is this one of them? No. What do we call this? That's a binomial. And what kind of binomial? It's linear. What does it say about linear binomials? They're prime, which means this can't be factored anymore. This one is done. Now let's take a look at this guy. This is a binomial, but it's not linear. It's got 2 terms. Quadratic means the highest power is 2. But, so it's not a linear. Is it a sum of squares? No. So it's not a sum of squares. Is it a difference of squares? Oh, it's 3. Sorry. Thank you for asking. Guys, I wrote that wrong. It's supposed to be 3. It still doesn't factor, though. All right. But is this a difference of squares? Is it a difference? Are they 2 perfect squares? They are. That's a difference of squares. I can keep going. So I've got x plus 3. What do I get if I split x to the 4th up evenly? X squared. And what times itself makes 1? You're going to make 1 a plus and make 1 a minus. You think we're done? Let's see. This is a linear binomial. What do we call this? That's true. Look on your primes. It's one of those. Which one is it? It's a sum of squares. Sums of squares cannot be factored, so that one's done. How about this guy? Is that a difference of squares? We can factor it again. All right? But I promise that's the last time. What do I get if I split x squared up evenly? And 1? 1's plus, 1's minus. Can somebody tell me? I'll give you some bonus points. Yeah. Can somebody tell me why we're done? Why these don't factor anymore? X plus 1 and x minus 1. Lil? They're linear binomials, so those are done. Good job. Thank you very much. All right. So I'm going to give you guys some practice problems. You do what you can while class remains. So let me ask some questions while he's writing. So, Alonzo, what do I always start by looking for? Very good. Amaya, if I have, oh, she's not here today. Armani, if I have 2 terms, then it could possibly be the what? Difference of squares. And Natalie, if there's 3 terms or 4 terms, what method would I use? Box method. Very good. Cal, can you tell me some types of polynomials that can't be factored? We talked about 3, but maybe only 2 of them are important right now.
They only have it.
Oh, okay. So there's only 2 here for you guys to work on, but Cal's not sure? Could be a difference of squares. But we talked about 2 that can't be factored. What are 2 that can't be factored? Anybody? Okay, so a sum of squares or a linear binomial. So there's 2 that can't be factored. Sum of squares and linear binomials. If you see those, you can just stop. All right, so try these 2 with the time that we got left. See if you guys can take it all the way home. I'm going to come around and check off your notes while you guys are working. Oh, so this one's hard to see, but I just know 3 goes in here and 3 goes in here. 3 divided by 4. And so we divide that into 16 by that. Yeah, good start. Yeah. You can't take out any x's, so this is still going to be up to 4, but this number is different, right? That. Correct. Now you're going to.
No, I literally did it. I literally did it. No. Tell him. No, I did.
Oh, this is Armand.
We did it again. We literally worked on it.
We'll talk about it.
I swear. my God.
We'll stop that team. Split it up. So, yeah, we need to do the squares. Now, right now, for now, this is X to the 4, and this is 6 to the Y. 4 there. That's not hard to say. Yeah, this is not going to change yet, but I'm going to split it. Now, our next split is so no DCF. I don't know if I got so you're going to start with the box. I'll use X to the 4 there. This is the one we did yesterday. This is the one we could do some guessing and check. Kind of a pain in the butt. 7, you don't. So this is like, for instance, you find the two numbers that multiply to make that guy. And then you find two numbers that multiply to make that guy. And then you fill the box. After filling the box, these two should combine to make 7. So that's that. That was a little bit different. That's what we learned yesterday. You should write some notes here. Can you get those from there? Thank you. So you can look on the class on campus or no school? Oh. If you wouldn't mind hanging out with me after class so I can get you caught up on what to do with it. Yes, you're good so far. So we wouldn't, yeah, we're going to. I'm going to put the answers up here. I know most of you guys aren't done yet, but I just want to give you the answers so you could have them in case you want to check yourself. But these are the answers I believe. I stole this one from somebody. I didn't do that in my head. But that was good. Let me see if it works. 4 -2. I'm wondering if this is supposed to be a positive. It doesn't. Like it doesn't back. All right, guys. So We are at the end of our day. They got it. The only thing I'm not sure about is if they have math every day. And it's in the morning.
You want to know what?
Before you come.
You want to know
What days do you have?
Mr. Baby, you already saw it out?
Yeah, you're good. All right, last time, okay?
I literally have to go to the bathroom.
First thing in the morning is before you go to the bathroom. Now, actually, I would like you to upload it for me in Google Classroom. She didn't say thank you. Oh, thank you for waiting. What's your name, sir?
DeAndre.
Yeah, very nice to meet you, Mr. Bailey. So the only